started. I know there's some committee members that are trying to get here,
and I think we're going to have people maybe coming in and out, but out of respect for your time, we've got a lot of folks here that I think are first-time participants in the meeting and kind of want to see where we're headed. And, we've got a lot of things on our agenda today, so I'll get started. I'm Bob Whiten, City Manager. I'm just here to make some introductory remarks. This Oversight Committee is an advisory group to the staff and the mayor and council. We have two council members that help serve as liaisons and members of the committee. The representatives from the committee I'd like to have introduce themselves now. As I said, we may have some people coming in later. Councilmember Johnson.
Brandon Johnson, City Council.
Brian Fry, City Council.
My name is Andrew Nave. I'm with the Greater Wichita Partnership, and I apologize, I'm going to have to duck out a little bit to catch a flight, but thank you.
Thank you. Like I said, we have several other members, some that we knew in advance couldn't make it when we switched the date. The other members of the team, I think many of them will be introduced as we go forward with our presentation. Because of the tight agenda and the number of people here, we may not be able to answer questions during the meeting. Actually, it will be during the meeting. We are available after the meeting, and then we've also set up a website that you can access through the city's website. It's a landing page where you can ask questions about issues you hear today or other questions you have about water treatment. So with that, what I'm going to do is turn it over to Alan King, our Director of Public Works and Utilities, who's going to make some introductory remarks. Because we have so many people that want to follow this process, there's some things that are probably duplicative for the committee regarding the background and how we got to where we are today. But Alan, I think, is going to talk a little bit about that, and then he'll be turning it over to other members of the team to talk about the design of the plant and cost going forward.
Thanks, Bob.
Thank you.
Alan King, Director of Public Works and Utilities, and the sponsor of the project. And just wanted to let you know that this is a very exciting project, very necessary for us to make sure that we look at through the interests of the city, not only now, but far into the future. The water treatment plant that we're talking about is going to be not only meet our needs, but also looks forward and anticipates what the needs are going to be. And I think we've got a really great design and a great team that has gotten us there. What I can tell you is this is another meeting of the steering committee. The steering committee has been very important in that it's been giving staff some input and some perspectives that we then take back and work on as part of the design process. So, and some of those are policy issues that help us make the kinds of decisions on this project. What I can tell you about the treatment plant is we're talking about a full 120 million gallon a day firm capacity water treatment plant. And that's important because not only does it meet the peak demands of today, but it looks far into the future, well past 50 years, and anticipates the kind of treatment plant that we're going to need to have in place. What I can also tell you is that it's flexible in terms of our two water supplies. We have one from Cheney Reservoir and another from a well filled up north. And this plant lets us use those in combinations in ways that we can't presently use our two water sources. And that helps us with our drought resiliency so that we can become more drought resilient in the event that we are in one of those 1% droughts. The other thing that we're talking about is it's fully redundant, and that's a really important concept, meaning that if any one part of the plant goes down, that we just throw some valves, change some controls, goes over to another part of the treatment plant, and the end user doesn't even notice it, and it gives us the time then to make the necessary repair on that failed component. So having a fully redundant plant is a very important thing in terms of the reliability. Then finally, it's a very resilient plant, which means that we're building it stout. We're building it so that it'll last. Recognizing that this last treatment plant has lasted about 80 years, we want to make sure that we have a good water treatment plant that can serve our needs far into the future. What I can say is, in a project, it's very easy to kind of reduce the scope and try to cut corners to try to meet the project objectives, particularly budget. What I can tell you, that's not the case with this project. We're ending up with a design that has a very robust, very well-built and well-designed treatment plant. And so I can tell you that what we'll be talking about today is that kind of a treatment plant. So what I'd like to do at this point is turn the meeting over to Ron Coker. He's the Vice President and Project Principal with Burns & Mack. And Ron's got some slides and some staff here to talk about the specifics of the project. Ron?
Thank you, Alan.
And I wish it was easy as just turn some levers and move the water to a different side of the plant. We'll talk about that. You'll see it's a little more complicated than that as we go forward. My name is Ron Coker. I'm with Burns & McDonnell. I also the project executive for Wichita Water Partners, which we'll talk a little bit about and who Wichita Water Partners is, because I know there's some questions related to that. As I get the slide advancer ready to go, I'm going to let just a few people introduce themselves, the people along this back row, if you would, other than City Manager Layton. Go ahead.
Tyler Pieski with Burns & McDonnell.
My name is Eric Berggren with HDR, Design Manager.
Ty McGowan with Burns & McDonnell. I'm John Mitchell with Burns & McDonnell.
And then
Also
Brian?
HDR.
Mike Haefling with Alvarez.
All right, we'll stop there at Mike, Joe. And then Brian?
Brian Meyer with Burns & McDonnell.
Okay, so what they didn't tell you was what they do on the project, which is important. Eric is our lead designer on the project, and we'll let Eric talk about the design here as we go forward. Ty's playing a critical role of balancing from design to construction, so Ty will follow the design of this project out into the field and make sure everything is delivered in line with how the design moved forward. Mike is our construction manager on the project, so he's going to be a key player in this. And then Brian is really one of the experts in water supply and water treatment here in the state of Kansas. So Brian has certainly an integral role as well. So with that, we do have a presentation. It is not a short presentation. You should know we'll try and move through it as expeditiously as we can. But we wanted to make sure we covered where we are in the project, so that you all had a good feel. And I'm going to start that by talking a little bit about Wichita Water Partners, because I know there's been some questions around who is Wichita Water Partners. Wichita Water Partners is a 50-50 joint venture between Burns & McDonnell and Alvarez Constructors. This isn't the first project we've ever joint ventured on. We've actually joint ventured on 35 projects before, including 33 water and wastewater plants. We've done that over a span of 25 years. And I think what's most important out of that slide of all of those numbers is the bottom number, which is in those 35 projects across 25 years, we've never had to come back and ask for a change order. We've never had a budget overrun. We've never had a schedule bust. So we've got a great record of performance for our companies together, and one that we're going to make sure we deliver for you on this project as well. We do have some key team members that are part of our team as well that form the bigger Wichita Water Partners. HDR is our lead our lead designer on the project. HDR is a top 10 design firm in the United States, number 6 in water treatment, 10,000 employees, $2 billion in revenue or so. Alvarez is one of the top contractors in the nation. Again, about $2 billion in revenue, a top tier contractor. And then Burns & McDonnell, which will play both on the design side and the construction side of this project, is also a top 10 design firm in the nation, and the number 6 design build firm in the nation. So we have about $4 billion in revenue and almost 7,500 employees. So in total, these 3 team members at the top of this org chart deliver about $8 billion of design and construction every year. And they deliver it successfully, and the vast majority of our business and our partners' business is built off repeat business, which means our clients are happy with the services we provide. One really important thing for us on this project, because it is so large and because it's going to be such an important piece of infrastructure for the city of Wichita, is to make sure we had lots of local partners on this project as well. Burns & Mac's been here in Wichita for 20 years, but we wanted to spread that and make sure not just other designers, but other contractors were able to participate in that as well. So you can see we have 11 total local firms. PEC, MKEC, GLMV, Schaefer Johnson, Dubois, and Dudley Williams are all helping support design on this project. The Gredeman Group's helping support communication, so like Burns & Mac, they'll be working both sides of the organization. And then UCI, Donlinger, and Wildcat are here to help us support on the construction side. This is just the beginning. As this project goes forward, we'll have hundreds of partners, local partners, that become part of this project. But this is a great core group, and it's important for us to have them here and at this point in time, because if you're going to invest $500 million or so, we want as much of that to be invested in Wichita companies as we can to turn those dollars into your community and build this project with folks that are going to be here and be responsible and be accountable for the delivery of that project, which we're all going to be. I do have members of our team here. If you guys would just raise your hands, if you would, to recognize yourself. They are a great team. We could not be more proud to have them as part of it. Real quickly, as we're going to talk about roles, so remember this is a design-build project, and just rules of thumb, design, or this side of this organization, is about 10% of the project. Construction, this side of the organization, tends to be about 90% of the contract. We'll be adding members both here and here as we go forward. A vast number here. This is where you really have the most impact because you have the most dollars to spend within the community. This is how we broke the project, and this is, I'm not expecting you to read all these lines and all these dots, right? But what I hope you recognize from this is Burns & McDonnell and Alberici play across the whole project. We're responsible, we're the contracting entity with the city, we're the ones that have our name on the line that says we will deliver this project for you. Our design partners play in key design elements like the design, support for the Wi-Fi application, the cost development, subcontractor outreach, and then they'll move across as you move into construction to support design and construction. The same way on the construction side. The elements that relate to construction, both early and late, are played by our partners at UCI, at Donnellinger, and at Wildcat as we move forward. So I wanted to just kick off with our commitment here. Our commitment to you is we know how important this project is, and every day we take it seriously. And we're going to deliver a project that you're going to be proud of as we go forward. We've got a world-class team here that's both national in scale and local in capability, which I think is important in the delivery of any type of project like this. We've been working close with city staff here for the last several months, reaching this point probably closer than they would like. And they would probably like for these numbers to quit moving, wouldn't you, Alan, just to let it settle down? And the answer is, well, they're not. We're going to continue to refine this project all the way up until we give you a price here on October 28th, and I'll talk about that as we go forward. And then that Wichita is home to much of our team, and you never let your hometown down on a big project like this, because in our business, you'll never sell a project not in your hometown if your hometown's not happy with the project that you sold. All right, so here's what we're going to cover. We're going to try and address any questions you have. We're going to go over the overview of the process to date. I've got Eric, who's going to give you a detailed overview of the design, probably your first real look at the design and the plant, I would assume. And then we'll talk about the costing, the schedule, savings that we found as part of this project. Here's just a little bit about our experience as a team. Just so you know, this isn't the first time we've worked for Wichita. Over the past 30 years, members of our team have virtually worked on every major water project within the city, or certainly contributed to those projects as we go forward. Alan mentioned the investment the city had made. I can tell you, I talked to other cities about this. I think Wichita, out of every community here in the central United States, has done more to invest in your water supply and system than any community I know. You have a very diverse water supply. You're one of the only cities in this part of the country that has both surface water, groundwater, and an aquifer storage and recovery project which lets you take surface water and replenish groundwater. So you are very well positioned for future droughts. The aquifer storage and recovery project has replenished the aquifer to about 98%. The last time I looked, I hope that's still the case. And it really positions you well. This project is the next big step in that. It's to provide yourself with a plant that's going to last for the next several generations as we go forward, and give you complete flexibility on how you treat which water source as you go forward. A little bit about the experience of the team. Lots of big regional projects. This team, Burns McDonnell and Alberici, did your aquifer storage project. That was a global project of the year finalist. So it was one of 4 projects globally to be recognized for the innovation that the city put forth. Fort Smith, Arkansas's water supply, Burns McDonnell's done both the supply and the treatment plant and is now doing the conveyance lines. The Florence Water Treatment Plant in Omaha, which is Omaha's largest plant, that HDR has done numerous projects, and then Albarisi's work up at Fargo. I'm showing you this not to say that these projects are the scale of your project. Your project's actually very large in comparison. I'm saying to you this, we have experience in this part of the country, and in water treatment work, that's important because where you live dictates what kind of water quality constituents you have and what you're doing to treat that water more so than anything else. So these plants are very relevant to Wichita's water treatment processes and very similar to those. That doesn't mean we don't have national experience. We also have national experience. This is HDR's work down at Tarrant Regional. This is the new water supply into the Dallas-Fort Worth Metroplex. HDR's work at Alexander Ora. That's the largest water treatment plant in the United States. It's in Miami right now. Burns and Mac work out in the Rocky Mountain region. These are advanced membrane water treatment plants that are really state-of-the-art. And then Albarisi's work in Toronto, Canada as well. So we have both local, regional, and national experience to draw from. In fact, if you look at our large plant experience and our large water pipeline experience, we have almost 40 projects that we can draw from that experience to make sure that we're delivering the right project for you. Okay, Ron, quit talking about experience and start talking about the project, right? The last bit of experience I'll show you is this one. I'd like Eric to come up and talk about this as well. So this is Omaha's new Platte West plant, and I say new, it's constructed just a few years ago as time evolves in our world. But this project's a 100 MGD plant. It's very similar to what you'll have in Wichita. It's unique for us, we think, because Eric and HDR were the lead designers. Eric was the lead designer on this project. Albarisi constructed this project, and Burns McDonnell permitted this project. So while it wasn't a design-build project, you have all three same partners here delivering your project that delivered this project. Eric, you want to talk just a little bit about this?
Say a few things about Platte West and what makes it unique and what makes it match the facility that you have here coming in Wichita, the Northwest Treatment Plant. First thing, like Ron said, it's about a 100 MGD facility, so it's on the scale of the treatment facilities you have here. It's a lime softening facility with 6 solids contact basins of this similar diameter that we're working on here. Granular media filtration, also similar to here. High surface pumping, chlorine disinfection with chloramine residual, all of the same major elements that we have for Northwest were completed here for the Platte West Water Treatment Facility. The one major difference you can see is everything's under one roof. We went with kind of the submarine theme on this one and put everything under one roof. But other than that, it is really identical to the types of facilities that we're going to be doing.
Which is more climate-driven than anything
Yeah,
else.
climate
right?
further north.
So a little further north, need things under one roof. Okay, I'm going to turn it over to Eric now.
Sure.
And we'll start with where we thought the project and what we thought the project looked like when we started this back in February.
So this is and Tyler's going to switch over here in just a minute.
And we're going to switch over to the model here as well.
Yeah. This is what we had at the LOI stage. So this was the concept when we first started, which you can see some large flocculation set basins and other things. And let's go ahead and just go to the next slide. And this is where it has evolved to. So this is a rendering here of the design as it stands today. This is what I'm going to be walking through in just a minute with respect to the model. So you can see some of the nuts and bolts and details of how this design went together. The design, as you see it on this screen, just for orientation, so this is Scoop Boulevard, right along here. And then 21st Street runs kind of along the top, hard to see. But that gives you the orientation. So generally north is to your left, and generally south is to your right. This facility includes the point in design where we were before we started our optimization process. So some of the things you see on here, we've already decided we went through an optimization process and reduced, like the water towers for backwash. I'll talk more about that in a little bit. There's 7 circular basins. We've found a way to optimize and reconfigure that so that we can go with 6. So some of the things on here have already been through an optimization process, but this gives us a picture of where we're at. Let's go ahead and jump to the model. So the model here, we've used we call a BIM, or Building Information System modeling software packages in order to actually do the design. So it generates a 3D product for which we can generate the drawings, plans, sections that you might see for a normal design project.
Yep.
This is the,
Important to note too, that's not grass,
no,
right? The blue pipes you're seeing are actually underground.
actually buried, yeah. So
Yeah.
we've taken away the earth, if you will, here, so that you can see all the pieces that are would be buried. So yeah, the piping in between structures, of course, would be buried for freeze protection and to keep it out of the way so you can get around and service things. But this is, again, it should look similar to that overall, and it gives you an idea of where we're starting. We're going to then now move into a step where I take you like a drop of water through the treatment plant. What is going to happen and how the design works with the treatment plant through the water. We'll also talk about some subordinate systems, chemical feed systems, solids handling systems, and then we'll talk about personnel areas, administration, maintenance, etc. So let's go ahead, Tyler, and start at the headworks. As Ron brought up just a few minutes ago, the real benefit to the city of Wichita is you have two distinct or primary water sources, the Cheney Reservoir source and you have a well field source. And so at the very beginning of the plant, we have the ability to control the flow from each of those sources so that the city can optimize what water source they want to use, whether it's a 50-50 blend of Cheney and Wellfield, or 100% Cheney or 100% Wellfield, and that's done in this very first building. And before we dive into that building, I'm going to give you a sense of scale. Can I borrow that? I think there's a laser pointer on that. That might be easier for you to see. See this little speck right there? That is a person door. So that gives you some sense of how big these facilities are. These pipes here are 64-inch pipes, so that's going to come up to your shoulder. These are large and massive structures in order to handle the volume of water that is needed for this community. So let's open up the lid. We're going to dive into this building. So as I said, you have two distinct water sources. You have your Cheney sources and your groundwater source. And we're going to use these valves here and these flow meters that you see in these vaults here to really control the flow and allow the city staff to set the rates at which they want to treat the water. So this gives them that first step of operational flexibility. Next, the groundwater itself, we're still reviewing this, but we're keeping it to discuss now, is aeration. Aeration is a process that can, is this cut out? Or, aeration is a process that can reduce the amount of lime we use and can also help remove iron and manganese, other things that show up in your groundwater or wellfield sources. And so we have designed in here so that the groundwater would come through and go through an aeration process. Aeration is just like it sounds. The water flows up from the bottom here into these trays, and think of like a waterfall. So as the water falls over the trays, it becomes in contact with air, and that does the work of the aeration process. And you have an aeration process similar today. So this is a extension of a concept that you already have. But the groundwater would be capable of being aerated in this process. Next, I want to talk about what happens. Now we have both groundwater and your Cheney surface water, and we want to blend those together. We want to mix that up so that when it moves on to the next treatment step, it is a homogeneous or a completely mixed solution so that it makes it easier for the plant staff to operate it, so that all the water going to the subsequent treatment steps is the same. It acts the same way, and we can treat it the same. And that happens in this structure here. Most of the time, the water will come into this middle. And there's actually a wall here, but we cut it out so you can see this mixer in the center. What's happening here is both your Cheney water and your wellfield water mix in there, enhanced by the mixer, and then flow over into these and split amongst your next treatment units, which are our solids contact clarifiers. And I'll get to that for a minute. This is a great place to kind of talk about that redundancy and resiliency that's built into this facility. So we have, this is the normal chamber, but you notice these bypasses on the top and the bottom. That allows us to move to the to these chambers if we needed to do maintenance on this chamber. So again, something like Alan talked about at the very beginning is that we don't have a point here where we can't do some maintenance, we can still flow water through the plant and meet our 120 MGD requirement. From this facility here, water flows off to the next 6 or 7. 6 is currently in the model. Solids contact clarifiers, and we'll do that next. So these solids contact clarifiers are really the heart of your treatment process. This is where the raw water that's been mixed and aerated comes into the center. So think of these things as kind of a donut. The center is the donut hole, and the outside is the actual donut. So the water comes into the donut hole and mixes. Is this?
I think the battery's dying.
Yeah, I'm just gonna turn it off, so I think it's almost more distracting.
She's trying to find you another one.
Is she? Okay, well, we'll go without. Raw water and the chemicals come into the center zone of the solids contact clarifier, and that's where they mix. So that's where we're adding our lime, ferric, other chemicals that you use today in order to do the heart of our treatment. That's where we're removing the hardness, where we're removing organics, where we're removing other contaminants that are in the water, and in that center zone. And that center zone is vigorously mixed. Think turbulent. It's got a gigantic either propeller mixer or turbine mixer in there, and so that zone is mixed up, and if you look at it, it'll be kind of a white, chalky color with the color of the line that we're adding. Now, after the work has been done to get all those contaminants that come out of the water, we go out of the donut hole into the donut, so into the outside ring of this. And the heavy particles, the particles we want to remove, settle to the bottom of that, and the clean water, clarified water, comes up to the top and flows over each of these spokes, like the spokes in that bicycle there. So the clean water flows over and on to the next step, and the heavy contaminants, things we wanted to remove, fall out at the bottom. Let's move on to the next process. One thing to note on those, now that I see it here too, those are 140 foot across. So that gives you another sense of scale. They're very big. This next building, the big rectangular shaped building you see right here is our filter building. That's like 470 feet long, 160 feet wide. That's, more than a couple football fields worth of size here in filtration capacity. So the very next step after the softening step is the filtration. And filters work just like you think of a filter working. It's a place where we remove any of the fine contaminants that are left in the water. So let's open this up, Tyler. The filter technology that we're using here, and similar to what you have today and what we did at Platte West and other places, is granular media filtration. So we have layers of anthracite and sand that the water flows down through. So as the water flows down through this media, this sand and anthracite, the small particles get lodged in between the granular media cells and they're removed from the water. So that filter is trapping those less small particles in the filter. Clean water goes out the bottom, out through these pipes here, and the filter itself holds the last bit of the contaminants that we have in there. A few items that I want to note on this filter building design. If you notice, all this piping is inside. So the large serviceable items for the city of Wichita in the future, valves, instrumentation, is all inside and accessible. You can see some stairs and access platforms that allows them to maintain this plant efficiently going into the future. The other thing I want to talk about is, and I don't know if we can back up or go forward, but these channels, you can see one of those gates, and maybe if it's too hard, maybe we won't worry about it, but those channels, the boxes you see there and there, are where the influent water comes in. You can see then this white, this gate here, that's a gate. So back to the resiliency and redundancy part of this, we can isolate small sections of the filter gallery and keep the rest of it going so that you could take a few filters offline if you needed for maintenance and still maintain the flow through the rest of the filter plant, okay? The last thing I want to talk about is that this whole building, it's all enclosed in a building at this point. So we have We have filtered the water. It is clean and ready to go to the distribution system plus one step. And so that's all enclosed in the building, keep it out of the elements. After the water is filtered, the clean water that goes out of the filter plant moves on to disinfection. And there's a lot going on in this figure here, so I'll go ahead and try and point these out to you. This is our disinfection or CT basin, this rectangular basin in the middle. We have some backwash pumping stations here. We'll talk more about backwash in a little bit. We have transfer pumping or finished water pumping here. We have high service pumps here and storage of clean water. Generator, I'll talk about that a little bit. These are the backwash towers, which we have optimized to not need now, so we can use a backwash pump. And there's chemical buildings here, and we'll get to those in a little bit. But I want to focus right now on the center part of this. This is our disinfection step. So after the water is clean, we will disinfect it with chlorine. The disinfection is a function of many things, but one of the critical ones is the time at which the disinfectant is in contact with the water. And so you can see this circuitous kind of route that we have, these baffling walls in there. That's to make sure that the water works through the CT basin in the amount of time we want, avoid short-circuiting and get the full disinfection that we're looking for. So we're applying chlorine.
Just scale as well. This building's also over a football field in size, right?
This is well over a football field as well. Like two side by side probably. So you've got the main field and the practice field, that kind of thing. For scale purposes, we do, like I said, add chlorine at the front. And then at the end, for our residual disinfectant, we're adding ammonia to form a chloramine. That's similar to how the city does it today. And that chloramine disinfectant residual then is what is distributed out to your customers, to the cities and homes of the citizens of Wichita. And that is what protects the water as it moves its way out into the distribution system. As I talked earlier, there's all kinds of different pumping applications, and we'll talk first about finished water pumping. So we have water that we will, from this, after it's been disinfected, transfer to the HES, your existing HES reservoirs pumping stations. So these pumps here are designed to pump water that's disinfected out of the reservoir and transferred to HES so that it can be distributed back out into the city. We also have, and I'm going to jump to the next one, let's go to the high service pumping station. In another mode for resiliency and redundancy, we have high service pumping right here at the treatment plant. And what does high service mean? High service means it goes directly from here to your customers, to the distribution system, to the residences and businesses right from this plant. So your high service pumping, the actual pumping that distributes it out to the community, is somewhat here and somewhat at what you have existing at your HES facility. Okay.
So if you have a problem at one HES, you can still push water.
You can still push water to the community from here. The last, I'm going to do a backwash, yeah. So the last pumping function that occurs in this station is backwash pumping. And like I said before, the towers, we've gone through an optimization process and we can do the level of backwash we want without the tower. So backwash, what's that mean? Remember we talked about the granular media and the filtration and how all the little particles are getting stuck in the media? Well, that has to be cleaned out. And so backwashing is just exactly like it sounds. We push water backwards through the filter at a vigorous and high rate, and that takes all of the media and separates it out and generates a lot of collisions, and all the little particles work their way, the dirt particles, if you will, work their way out of the media and go out from the filter so that your filter is clean and ready to go into a filtration mode again. So we're going to use pumps to pump water backwards through the filters in order to clean that media. That water that is clean, or that comes out of the filter after the backwash, will go to a backwash equalization basin. So that water is good water, and we want to not waste it. And so we can take the backwashed water and return it to the very beginning of your plant and treat it again. This allows us to reduce the amount of water that we need to take from Cheney or your well field in order to produce water going forward. So this is an efficiency step that allows you to recycle some of that water back through because it's not, it can be used and treated again. So we have basins here that collect that backwash water and then pumps that return it to the head of the facility. And those pumps return it at a steady state all day long. So the backwash may take 15, 20 minutes and generate a large volume of water, but we want to return it steady the entire way back through the plant. So that's what these basins do. Remember back to the solids contact clarifiers, we talked about adding chemicals. Chemicals, as you might imagine, in water treatment have, go ahead and go to the chemicals, have a specific design-related items that warrant keeping them in separate buildings. So we have all of our chemical systems to do the treatment of the facility in their own buildings so that we can manage the ventilation and manage the safety-related items and keeping those chemicals separate. And so we have dry chemicals like lime here, and we have liquid chemicals like polymers, other things that you use there. So we're going to cut in and take a look at the dry chemicals. This is the lime feed system. So we have dry storage here, comes through the building, is slaked. Lime is one of those chemicals that as dry, you have to mix it with water to make it useful for you, and so that's called a slaking process. So we're going to slake it, and then we can pump it out to the different solids contact clarifiers we've already talked about. Similarly, if we go to the liquid side, we have a series of bulk storage tanks and what we call chemical metering pumps, pumps that pump a precise amount of liquid that'll go out to the different treatment units as well. We talked about disinfection. The disinfection chemicals, your chlorine and your ammonia, are also in their own building for the same reason that these are in their own building, to maintain ventilation rates and safety for these chemicals. And so we're storing both chlorine and ammonia in their own separate building, and then they will be metered out to the rest of the facility as it's needed. The last thing that we want to talk about from a treatment perspective is solids. So at the beginning we talked about the heavy solids going down to the bottom of the solids contact clarifiers. Those solids are periodically pumped out and to be disposed of, and they go into these thickening basins here, and then these pumps will pump them to the city's existing lagoon system where your solids go today. So that's the solids management portion. That kind of takes us through the high level of the design. As you can see, there's a lot of detail, a lot of piping, a lot of valves and parts, but I hope you understand now how we get water from the beginning to the end and all the facilities that support that and the design level that's gone into this at this stage. One thing to move on, though, to talk about is you got people that run these facilities and operate these facilities, and so there's personnel spaces as well for the treatment plant. Let's go to operations first. Oh, backup power. Thank you. Backup power, I almost forgot. So part of the resiliency of this facility is providing backup power. So in the event that you would lose utility power, we have a series of diesel generators that would provide power for the facility so that it can be maintained in the event that you would have power loss. Now we'll move on to personnel areas. So the first one's operations. Operations are people that are on the day-to-day front lines of operating this facility, of monitoring the large SATA screens, watching chemical feed rates, flows, etc. The guy that sets the flow rates that we talked about at the very beginning, this is where they would be housed. And this building is a hardened building designed to withstand severe weather, and so in the event of a potential tornado, they would not have to leave their post. They can stay there and continue to work, and that provides for the resiliency of this facility. And this sits just adjacent to the filter gallery, so that's kind of in the heart or center of the plant. The next major personnel area is maintenance. You have several maintenance functions, whether it's repairing valves or calibrating instruments. And so a maintenance facility allows your staff to maintain this well into the future so it can last you like your current one, 80 years or more. The maintenance facility consists largely of personnel areas like locker rooms, office space, and then a huge amount of maintenance space. And these are tailored to the type of job that they might do. So if you're cleaning and working on a little sophisticated electronic instrument, we have a special room for that so that it can be clean and neat and they can work at a table. If you're overhauling a pump, you want to be out in the general maintenance area. That might be a dirtier job or a messier job. We have room for storage of parts and equipment. We have specialized room for flammable storage, sandblasting and painting, as well as welding. Yeah. Always technology, isn't it? We need to get it back into this room and fix it, right? The electronic stuff. But these facilities are separated. The point is that you have adequate facilities to do maintenance, and it allows them to separate the types of tasks so that one doesn't contaminate or bother the other. The last personnel area that I'd like to talk about is the administration building. This is the front door to the treatment plant. This will house administrative personnel, but the largest portion of it, if you cut down through it, is the city's fully accredited laboratory. So this is where they're doing tests to ensure compliance with the Safe Drinking Act, as well as testing that they do for other communities. So that kind of takes us clear through the overall design process, and this model that you see here is the culmination of lots of input and lots of people's effort, both for the city and the city's engineer, the owner's rep, and HDR, everyone on the team. So,
Any questions on the design? All right, thanks, Eric.
there you go.
So while Tyler moves us across to back to the presentation, so there's again just a view of the plant, and then looking a little bit more towards the east of the facility. I'll take a quick minute to talk about pipelines, or how we get water from this facility back to your current facility. So in the original plan, there was a new 72-inch pipeline proposed to go from the new treatment plant down to the current plant or current facility as we go forward. One of the things that we looked at early in the process was, does the city have other infrastructure available to use so that you don't have to build another pipeline to connect these facilities? And the answer was you do. And it's in pretty good shape. So we have worked with the city to access and utilize that infrastructure and take advantage of the investment the city's already made. So you'll see now the blue takes advantage of what would have been a raw water supply line coming to the old plant. Now that we've treated it, we'll use it as a finished water supply line down here to the Hess pump station so that it can be pushed out into your system. What you see in orange and yellow then are other elements of moving water that we're considering. So one of the things, the city really wanted a couple of things with respect to movement of water between these two facilities. They obviously wanted a way to get it there. They also wanted a backup way in case they had a catastrophic failure in that line. So there was another existing raw water line that can be repurposed as in an emergency condition. And then they also need to move local well field water from down here back up to the plant. So that can move one of two ways. It can move back through an existing pipeline here and then construct new 42-inch pipeline of about 4 miles across to get that local well field water back to the new plant. Or we can have a dual purpose line. And this is one of the things that we've identified as a potential cost savings that the city will spend the next few weeks looking at, which is, could we use this line in dual purpose? So on a daily basis, even as an emergency line for your finished water, you can't connect it to your finished water system. You have to have a physical disconnection from your finished water system. So we could use this line to pump local well field water up to the plant, the 99.9% of the time that you would need that. And then if you have a catastrophic emergency, you can then connect the pipeline to the finished water supply, clean it, disinfect it, and use it to get water back down to your pump station. So we think it's a great alternative for the city to consider. As part of it, it's about a $20 million swing in the cost of the project. I'll show you that here in just a minute. And something that we hope can be of some benefit to the city. Okay, so lots of slides there. I know you had lots of model, probably not very sexy facilities compared to what you're used to, but for water plant designers, those are pretty sexy facilities to look at. So the things I would like for you to take away, you've got a project that's going to have maximum flexibility. You're going to get the city's going to be in a position where they can treat any of their water sources. They can do it well. They can flip back and forth between the two easily. You've got redundancy in every system. There's no single points of failure in this project, which is important because you have one water plant, and we always have to be able to provide water out to the community. And then finally, you've got a plant that's going to last multiple generations, similar to the plant you have now. The progressive design build process now, so we walked through the design, but let me tell you just a little bit about this, because I'm going to show you some costing here in a second, and I hope this helps prepare you to see some of that. So what happens in a progressive design build? You don't design the project and finish the design and then price the project and then build the project. You do all those things at the same time as you're going forward, and you've got to be very fluid, and it's an iterative process that you go back and forth all the way through this project. They tend to be broken out into, a couple of different phases. So the first phase, that says phase 2, that should actually be phase 1, is the concept design development. So here's where you were when the WIFIA LOI was submitted, the letter of interest. We were at 5% design. The project was costed based off standard metrics that say per million gallons of water, this is what it should cost to construct, per square foot, this is what it should construct, but not very much design. We built an early cost model, and we worked through that early cost model in the early phases of the design process to help inform decisions. Once we get to about 30%, then we can move towards the primary costing model. So now we're getting pricing in from contractors, we're getting pricing in from vendors. It's much more realistic on what the project's going to cost, and we make better informed decisions as we go forward. And then as we get to that point, we have a project optimization period. I'll show you exactly what that means here in just a second. Then phase 2 of the process, really then after the price is set and the city says, yes, we like the price, we're ready to move forward, then the construction team and the design team moves on to work package development. Work package development's really important when you're trying to build local capacity. You want those work packages sized so that local contractors can win those projects and deliver those projects. You want them sized so that emerging businesses can participate in this process. So it's a key element, and it really helps inform even how we're going to design or go through final design is what our strategy is in developing work packages. We'll complete design. We'll work through then the procurement of those packages to push them out to contractors and vendors, and then we'll start construction, run through construction, and start startup. So here it is in a timeline format. So we started with 5% design. We go through this iteration with our early cost model. We get to 30% design. We go through another iteration now that we've got real cost data. And then we move towards defining what the final costing is, and we provide a guaranteed maximum price. We're the price that the city will never pay more for this project for, right? This is where we are in the process. I know there's been a lot of discussion on a contract extension for us. We were actually scheduled to deliver that GMP on October the 4th. We asked for a contract extension so we could take an extra 3 weeks, deliver that price on October the 28th, because we believe there were more savings to be had. That pipeline was one of those examples of savings that we think that it's worth the city considering. And now the city will have an opportunity to do those here in the next few weeks, so that when we deliver your price on October 28th, that is the guaranteed maximum price. That's the price that the city can count on before they submit their WIFIA application.
So Ron,
Yes.
if I might say, then we are going to hit our original deadline then for applications submitted to the feds.
You are. There's absolutely no delay in the WIFIA process.
There's no delay.
There's no delay in the WIFIA process at all.
Wonderful.
And you might say, well, gosh, I thought it was a longer extension than 3 weeks. Well, it was about a 2.5-month extension. We're going to deliver our price estimate on the 28th, and then we're available to support the city. The city's been going through this process, and the city's owner's engineer, Garver, has been going through this process with us. So they've seen costing all the way through, but now they need a chance to really dig into the cost model, understand the pricing, make sure they agree with the pricing and everything that's been delivered as part of our proposal, and that occurs in early November. So we're just, the back half of that contract extension, or that extra 2 months, is just to allow us to help support the city in the WIFIA process, support in the SRF application process, and support any needs they have in review of the proposal as we go forward. All right, some real quick stats. This is a big project. I know you've got some big projects underway in the city. This is a really big project. Almost 1.6 million man hours to construct this facility. with a peak of about 350 on site in the project. 70,000 cubic yards of concrete, 18 million pounds of rebar. One thing that's really important, I'll show you how this fits on the schedule, 662,000 cubic yards of dirt that we've got to move around that site to get the site ready to be built upon. Lots of process equipment, 17 miles of pipe in the plant. There's a lot of pipe in a water treatment plant this size. The two things that I think are most important, I put in the bottom right. That is, there's already been 200 local Wichita and Wichita regional firms or companies that have participated in the pricing exercise. So it is not just the 13 companies that you saw in that original organization chart. We have already reached out to the community, and we have a ton of local companies feeding us pricing information back in to make sure we've got realistic pricing as part of the project. Then the other thing I think that's important is that about 90% of the construction, the direct construction elements have already been competitively priced. So it's not enough for us just to give you an estimate and say that's what we think it's going to cost. We're getting multiple estimates, we're getting multiple pricing from different contractors, and we're trying to make sure that the city gets the best pricing as we go forward. I see a hand up. Are we taking questions from the public, or do you want to finish the presentation?
I think we are on such a tight schedule, you probably need to finish the presentation. Okay. If there's time at the end, we might be able to.
Okay, we'll do that. Okay, so here is what I call the up-down chart. I'm pretty plain and vanilla in what I do. What more sophisticated people call the cost development curves associated with the project. So what you're seeing is the price of the project as it progressed from the start back in February all the way through where we are today. This is not meant to be a detailed accounting of the project. This is meant to give you a sense of how does a design build or a progressive design build process work. And I can tell you, I'm responsible for capital programs in Kansas City, Jackson, Mississippi, Shreveport, Louisiana, worth about $6 billion. And I can tell you, every project goes through this cycle. And I'll walk you through that cycle. You start with a very conceptual estimate based on industry norm. As you work through the design, the designers and the operators and the people that are going to use this facility really start to think in detail about what kind of flexibility do they want, what do they need from a process standpoint, how does it work. You have a little bit of a reality check and say, okay, guys, this is great, but we're way outside the scope of this budget. We need to think about how do we pull it in. So we start looking for opportunities to pull this project back into budget. You see this went through 2 cycles of that. Right here is where we went from conceptual pricing to actual pricing. So you'll even see a little difference here in those parts. That's why that is, because now you're working with actual pricing. Same thing, went through the finished the design, working through the pricing. As we started to look at how to optimize the project, we started looking for value engineering opportunities, really optimizing the process to bring it back to where it needs to be. We would love to spend an unlimited amount of money on your water plant. I don't think you want us to in the end. You want a plant that's going to last you for multiple generations, but you also want a plant that is cost effective in both capital and operations, because in the end, WIFI is not a grant. WIFI is a loan. It's going to have to be paid back. So we want to provide the most value for the city at the least cost that we can provide. Now I'm going to show you tables of this, but I can tell you this number at the end is the only important number we're going to talk about as we go through these tables. Okay, so I'm not going to spend a lot of time progressing through. So again, here's where we started, our LOI budget. I talked about removal of the pipeline, but it's not just an $87 million savings, because there's a lot of other pipe work that had to occur to take that project out. So you're seeing the push and pull, or the give and take, as you go through the design process. From about May through June, again, you're seeing changes. Here you're seeing a change with one of the properties on site. With Cox Manufacturing, we were able to reorient the site and save money. You're also seeing a lot of project fluctuations here, changes to the process, improvements in the process as we go forward. As the cost progresses even further, right here, I pointed, now we're in actual cost, right? Right here, I had pointed to the point where we said we're really starting to look for optimization and value engineering. You can see that in these numbers. Above it, you can start to see the impacts of uncertainty in the construction market. Remember, we're pricing a project that's going to be complete in 5 years. And there is a lot more uncertainty today than there was a year and a half ago when the first budget was developed. Uncertainty around trade, uncertainty around inflation, uncertainty around what the economy is going to be doing in that 5-year period. Pricing reflects uncertainty. Contractors they quantify that risk and they adjust their pricing accordingly to what that's going to be. So the great thing is even though that's gone up, we found ways to pull costs back down. This last list, in particular, the ones in red, are 4 items that the city is going to have an opportunity to review. 3 of those relate to that pipeline project. The 4th, Eric mentioned aeration, is still under consideration on whether it's got a cost benefit in the operations of the facility. I told you that the most important number is the number at the end. So what we have told the city is our price on October 28th will not come in above that number, which is 508, just right around 508 million. So 2 things about that number. One is we always had targeted being below $524 million because we know the city has to pay $10 million for a new substation, and we know the city wants to pay what they paid for us as a stipend to be covered in that $524 million WIFIA submittal. So this number gets us to that point. The other important thing here is that if the city determines these are valuable opportunities and can be taken out of the project, that number then comes down about $20 million to $488 million. So not only are you on schedule, Councilman, you're also on budget on the project. We'll take the next 2 weeks to finalize our numbers. I told Alan before we started, there's 55,000 line item inputs into this estimate. 55,000. The numbers are moving all the time as you move forward. That's why I said that's not a detailed accounting. I can't give you a detailed accounting at that level. It's too high a level as part of it. Focus on the end number, and then Alan and team will focus on how did they get to the end number, and does the city agree with that process and what's in that number. Okay, if you look at just kind of by category, things that have occurred. So as the design progressed, we've seen ups and downs. We've seen ups and downs in decisions that you make related to, hey, I'll spend a little bit more on capital if I can save more money on operations. That's what you see in OpEx versus CapEx. More flexibility in the operations. I talked about the market impact or the uncertainty of construction pricing. Some of these are just utility preference that we go through, and it might be risk sharing or it might be risk, moving risk as part of it. And then you see the optimization of value engineering components, and then our contingency and fee reduction. That's really built around 2 things. One is, as the price comes down, our contingency and fee come down as well. So it's riding that curve. And the other thing is we committed to you back in February that we were going to deliver your project under budget. We're going to deliver your project under budget, even if that means we take less money out of the project to do it. Here's the $21.3 million that we talked about on the last chart. So I hope your cost takeaways are, when you get that proposal on October the 28th for no more than $508 million for us, 508.1, when the city accepts that proposal, the city no longer has exposure to inflation. The city no longer has risk of cost overruns, and the city has delivered a project that's in line with what WIFIA has, or EPA has already approved for your WIFIA loan. So those are big deals on a 5-year project to have that risk shift to the design builder. All right, well, we didn't just have design goals, we also had operational goals. So new facility, we're treating to a new water quality standard as part of this facility, and we're also treating both water sources in much more flexibility. So one of the targets we had, or were given as part of our contract, was tell us what the baseline cost of this facility, what you expect from an operational standpoint, and then beat it by 10%. So we both have to justify the baseline, and then we have to justify what we think is going to beat that baseline. So we had an additional goal of saying we don't just want to beat it by 10, we'd like to beat it by a little more than 10. We only look at chemicals, energy, sludge disposal costs. We're not trying to look at labor. because the city will have that, its own calculation. I would assume labor costs will go down with more efficiency in the plant, but if the plant's understaffed at the current plant, that may not be the case. We'll let Alan and team work through that. So we're just looking at chemicals, energy, and sludge disposal costs. The model development included both physical testing on chemical, right? What's jar testing is what we call that. How much chemical do you need to reach the treatment parameters that we want? And a model that then demonstrates that or models what it's going to look like for the plant as a whole. On chemicals, you see what we think the baseline plant or the baseline design would have been, and then what we think the new, the optimized design will be. Same thing for energy and sludge disposal. You see a baseline number and a projected number and the difference. So when you look at that sum, we projected the baseline plant at about $64,000 a day. We think with the optimizations in the process that have occurred, it'll be closer or much less than that for about 26% reduction from the baseline to where we think we are. Not many people think about operations in dollars per day. So if we think about that annualized numbers, that's about $6 million of annual savings through the process optimization. If you want to look at it over a period of time, 20 years, it's about $123 million. I told the city manager the other day, if you want to look at it over 80 years, which is how long your plants lasted, that's about $500 million.
It's paid for itself. Yeah, it's paid for itself.
You just got a free plant. So the operations takeaway, you're going to have a more efficient plant to operate. It's going to be more flexible. It's going to be better for the operators to be able to deliver water. You're going to have a plant that's better for the environment. Often people say, what do you mean better for the environment? I mean less chemical usage, less sludge disposal as part of it, and you're going to have maximum value to the ratepayers as well.
Ron?
Yes?
Real quick, as you continue to work through this, would that number conceivably even go lower?
Yeah, you're really just comparing baseline to projection. So I think we're far enough through the process changes that you're not going to see it. If aeration, for example, comes out, that number would go lower.
Okay.
Because that's a cost. But the pipeline is probably not going to change it a lot, other than maybe energy costs of if one takes more pumping than the other.
Well, it's already pretty significant.
Yeah,
Every little dollar
It's
helps.
a significant number. So we're almost done. I thought we'd talk just real quickly about the financing so you understand the financing package, and then we'll be open to questions. John Mitchell's going to come up and help me do this. John, we're going to go really quick because we've already kept everybody an hour.
So we heard Alan talk about.
Here you go, John. Just right.
So we heard Alan talk about how critical the project was. We heard Eric talk about the resiliency and the robustness of the design, and we heard Ron talk about the size of the project and really that it will take 5 years to deliver the project. And because of all of those things, it's really important that we have an equally robust plan to finance the project. And the city staff and design team, I think, have done a great job in designing a financing plan that's robust and can finance the project. And really, this will be done with a package or a blend of loans. A loan from the Kansas Department of Health and Environment, that's the state revolving loan fund loan, and WIFIA, the Water Infrastructure Finance Innovation Act loan. Both of those loans are low interest rate loans. The SRF loan currently has an interest rate at about 2%, and that payback term is fixed at 20 years, very rigid and inflexible on the 20-year payback term. The WIFIA, on the other hand, has an interest rate that's similar to the 30-year Treasury rate. Today, that runs about 2%, so it's about the same today as the SRF loan is. The advantage is the flexibility of the repayment terms. The WIFIA loan can be repaid over up to a 35-year period, and that 35-year period can begin after construction is complete on the project. So what that allows the city to do is sculpt or design their repayment structure around the WIFIA loan that can spread out to 35 years. And that levelizes the repayment and also minimizes the impact on the ratepayers as that loan is paid off. So we're moving forward now with the application for the WIFIA loan. And this really just lists the important elements of the WIFIA loan. What EPA wants to know is exactly what's going to be built, how it's going to be built. They want to know that there is a plan in place to operate and maintain the asset over the life of the loan. And they want to know that there's a plan to manage the asset over the life of the loan. So those are really the critical elements of the WIFIA application. And all of those things right now are on track to be assembled and submitted by the WIFIA deadline. So we'll talk just briefly about the Kansas SRF loan activities. And probably what is the most critical here is that this summer the project team got the project listed on what's called the intended use plan. So that makes the project eligible for the state revolving loan fund loan. That's one of the very first steps and one of the most critical steps. By the end of the year, the SRF application would be submitted, and then from that point forward, it really only takes 90 to 120 days to close the loan. We've got almost a year built into the schedule to close the loan, because the only constraint here is that it has to close before the WIFIA loan closes. And then from that point forward, KDHE is involved in the project all the way through construction and into startup and commissioning. Very similar timeline for the WIFIA loan. If you remember back in October of 18, the city was invited to apply for the WIFIA loan, and that was a huge win for the city. Only 39 communities in the country have the opportunity to apply for this loan, so that's a great accomplishment for the city. The WIFIA application is coming up. It's due here October 30th. Everything is on track to meet that deadline and have the application submitted. And then it can take up to a year for EPA to review, approve, and get that loan closed. And then from that point forward, the process works just the same for WIFIA as it does for the state's SRF loan.
Yeah, so a couple of things I think to be aware of. One is the WIFIA application is due October 30th. I told you we'll submit our pricing on the 28th. You don't have to have our pricing to submit the WIFIA application, but the thing you want is you want to know I've got a project that's going to fit within the loan amount that I'm asking for from EPA. We're telling you that it's going to fit today. We'll give you that as a firm proposal on the 28th of October so that you know when you go to EPA, you've got the funding available to deliver the project. I think the other thing that's important to pay attention to here is the end date. So this project is an end of 2025 timeframe. There is a way to pull that forward. There's actually a couple of things that are key in pulling that forward. One is, John said there's a year delay in the project as WIFIA closes, or as the EPA closes the loan. There's an opportunity to do some early site work within that year. If the city is interested in moving that project forward, we can slide that construction schedule up, get the site ready so that when WIFIA says go, we're already down the path and moving. I think that has more benefits than just moving the end date up. It also gets the community involved in the project and moving the project forward. One of the biggest challenges you have in big infrastructure projects like this is everybody gets excited about the project, and then during the year while EPA is reviewing and approving it, everybody says, what happened to that big water plant project that we were doing as part of it? So it's a way to keep the project active and moving in the community as well as provide a benefit. The other is to really focus on this commission and training, and rather than just have it set here at the end, to slide it up so that we can start commissioning and testing and training before final or substantial completion. If we do that, we can move this project forward almost a year, which in our opinion then puts the city in a great position. It shows that the project will be on schedule. You have the opportunity to accelerate, which in our mind means less risk to the city, right? You do have an 80-year-old plant. It's well maintained and it's operating sufficiently today, but it's an 80-year-old plant. And I know that everybody here in Wichita is anxious to have a new plant so they don't have to worry about that asset as they go forward. Also, We have lots of people helping us review this project as we go forward too. So the part of the WIFIA application, we're part of the WIFIA process and the state process, we have to go through all of this permitting. So you have lots of eyes on this project, making sure it's the right project, that everything is done in accordance with state and federal standards. The local elements really happen in the next phase, but what you see in the federal and state levels are a lot of that's already ongoing with those agencies. So next steps, and Alan, jump in here wherever you would like. We've told you that I believe there's another steering committee coming up on the 24th. We talked about in that steering committee talking about emerging businesses. I know Councilman Johnson in particular has asked questions of us related to what's our plan for developing a supplier diversity and emerging business plan. I'm happy to answer questions on that today, but our intention is we'll present that. We'll also talk about the community outreach elements of the program before the 24th, or on the 24th. Our price will go into the city on the 28th. The WIFIA application goes out to EPA on the 30th. And then you've got some other steering committees and city council reviews before you get to an SRF application to occur. I believe in November, the city's going to be looking at the pricing, and then when you get to late November, you'll start presenting the proposal to the city council as a whole. So with that, I will close. Thanks for your time and your leadership. This is a really important project. You know, this is the second largest water wastewater project that's being designed and built in the U.S. right now. Houston has a $1.6 billion plant. Wichita's got the next biggest plant as you move forward. You've got a world-class team working on this project, but it's also a local team, which is just as important as being world-class and having world-class experience as part of it. You've got fantastic designers and contractors here in Wichita. They have taken care of your facilities well for the last several decades. They will be a great asset and partner in taking care of these facilities moving forward as well. We'll continue to optimize the project. If there's an opportunity to save money and still enhance the project, we'll try and find it as we go forward. And staff has been fantastic to work with, as has the Garver, the city's owner's engineer, in helping us evaluate those opportunities. I can tell you, everything that we define as a savings isn't approved by the city. In fact, I would say maybe half are those, because the city's really giving it a critical eye to say, no, we're not going to take any less on operational flexibility, or we're not going to take any less in redundancy as part of that. So you can be assured that things that have been accepted and included in the project have been well vetted and don't do anything but improve either the operational aspects of your project or the capital delivery aspects of your project. We're committed to answering as many questions as you have. I know there's been a lot of questions. Happy to answer those. Most important for me, and I tell you this, that this is our commitment to you, is that we are going to deliver this project on time and on budget. That is what we do. We do it on billions of dollars worth of projects every year, and we are proud to be doing it for you on this project. So that's all I have, Alan. I know that was a long time, probably longer than anybody expected as we go forward, so I will turn it back over to you.
Well, thanks, Ron. Appreciate the presentation. At this time, it's an opportunity for the members of the steering committee to ask any questions before we go ahead and adjourn. And then after the adjournment, I understand we're going to leave some amount of time for some of the city and design builders representatives to answer questions to y'all. So at this point, I would open up to the committee.
So, thank you, Alan, and great presentation, Ron. The key takeaways are very impressive. I know that there's some concern early on with a connection to the Flint crisis. Could you share that with us?
I can. So I won't go all the way back through the PowerPoint to show you our team members again, but I certainly have been made aware of that. Unfortunately, that was a rumor that has been started a long time ago as part of it. I can tell you that there's not a single member of our team that have any connection to the project or to the ongoing water crisis there. The members of our team are all local members, and we have 3 national members that are part of it as well. That's Burns & McDonnell, HDR, and Alvarez, none of which have a connection to Flint.
Thank you.
So I I was going to bring that up as well. I would like you today, though, since we do have media here, and I want to make sure we get out. You don't have to go into too much detail, but what are some of those efforts with women and minority-owned businesses? And at our last meeting, I kind of mentioned possible training opportunities for Wichitans to get into this type of work, since we'll have so many job opportunities with construction with the water treatment plant. So could you kind of elaborate?
Real high level, I'll give you a real high level on that, and more detail maybe next year in committee meetings. So Councilman Johnson's right. A project like this brings with it great opportunity. You have very few projects, capital projects, that you can look at and say, a year from now, we're going to be doing construction on this project, and it's going to go for 4 years after that. You're actually blessed because you have several big capital projects that you're going to have to do in the future, so it creates great opportunity to build emerging businesses, to build minority and women-owned businesses, to prepare not just EBEs, but all firms here in Wichita for the work that's coming, and help them better position for that work. So we're really starting to develop that plan and that process, because we know that effort starts long before the first construction labor hits the project. We think it looks like a combination of things. The first, we're going to build off Burns & McDonnell's supplier outreach program. It's an award-winning program. We know that often the challenges for emerging or developing businesses are, I can't get bonding, therefore I can't be part of the project. We've got a method we call SubGuard, or a product we use called SubGuard, which alleviates those bonding requirements for businesses that have that trouble. It still provides protection to the project, but it often gives a new or developing business the opportunity to get those first bits of experience, to build that resume so that they can get bonding capacity in the future. We also recognize that as businesses grow from one scale to the next, small businesses in particular often have trouble with cash flow through that growth period. So we'll have a program that deals with quick pay or fast pay for businesses that are in that position, so that you can get them paid and they can continue that development process as we go forward. We are big believers that businesses need to be strong not just through contracts as well. So we're going to have two things related to that we're planning on, and these are all in discussion and development with folks here in the city as well. One is Burns & McDonnell's given 7 scholarships to the Tuck Minority Business Development Capacity Program. Tuck is the business school at Dartmouth. These are 1-week sessions that are really, it's world-class educational opportunities, or Ivy League, since it's Dartmouth, might be a better way to put it, where disadvantaged business CEOs can go learn about how do I build my business stronger. We provide those scholarships because we want to partner with those businesses. These are our partners. We want them to have strong, viable businesses, so that as they're delivering work, they're going to be successful in delivering it. 2 of those 7 scholarships have come to companies that are on your emerging business list here in Wichita. Our commitment is that we will enhance that and do at least 2 more as we start this program off. I would say we'll probably do more than that, because it's a great program and the businesses just rave when they come back from it. We'll take that one step further and we'll bring an educational program here as well. This is something similar to what we've done in Kansas City. We actually brought Dr. Fred McKinney. Dr. Fred, as he's affectionately known in the industry, headed up the Minority Supplier Council for the New England area, and then took over the Tuck program. He's now at Quinnipiac, so we'll bring Dr. Fred back, and what we do is we put on a 2.5-day educational component, and in Kansas City we invited 30 local business owners, CEOs, of minority, women-owned, or disadvantaged local businesses to come and participate in that program. We didn't do that alone. We partner with Kansas City Power and Light there. We're now Evergy, DST, Sprint, and the City of Kansas City, because we all know that we don't just want to prepare these businesses to do construction, we want to prepare these businesses to do whatever they do as part of it. So we're going to plan on that as well. In fact, I'm hoping to get Dr. Fred here in a couple of weeks for the early planning of that. We want that first program to occur early in 2020, so that we get the advantage of this year we have to prepare for construction. The final element, which you mentioned, is workforce. This is a great opportunity for a workforce development program, because you've got enough lead time to prepare workers, train workers, and you've got enough time at the back end for workers to get established and really develop those skills. It does no good for us to train somebody if they don't have a job to go to, It does no good for us to train somebody if that job's not going to last long enough for them to get established in the field that they're in. So that program is under development as well. I know the city has done a program with Wichita State Tech and Spirit, I believe. We've looked at that model. We really like that model. We're going to commit to funding a program like that out of our profits on this project, and if we can partner with the city on something like that, that'll be great as well. So really high level, is that a sufficient answer?
Yeah, that's great. I appreciate it.
That was probably not high enough.
That was great. One last thing, I definitely appreciate the presentation, lots of wonderful information. There was some concerns and comments from the community about your experience, so I appreciate you providing tangible examples for us to look at and for anyone concerned to do some research on. So thank you.
You're welcome. Thank you.
I'm sorry, I just thought of another follow-up question. And is it John?
Yes.
Yes, John, thank you. Maybe you can confirm this, but I don't know that folks really understand the significance of the WIFIA and the SRF loan programs. I've been told that those could amount to as much as $76 million savings over the course of it. Is that an accurate figure?
Yeah, well, we haven't run the actuarial of WIFIA and SRF versus bonding, but it is accurate to state that the rates that are being quoted today are just a smidge above 2% for both the WIFIA and the SRF programs. A year ago today, the WIFIA program was about 3.5%. So it's declined, it's dropped quite a bit. And because of the inverted yield curves we're seeing today. So I think really advantageous that we're in this cycle at the point that we're in it. But the interest rates are about half of what it would cost to bond the projects. So that will translate into the cost of money being about half what it would be to bond it.
I think the WIFIA as well, the flexibility in the repayment and the time frame are very important. It essentially allows you to spread the cost of this project across generations, so that one generation is not having to fund the rebuild of infrastructure that future generations will benefit from, which in the world of water bills, you want that as competitive and as acceptable as possible to all those in the community.
Councilmember Fry, staff member Ben Nelson, he actually did a financial analysis, probably the number that you're thinking of. Ben, you want to?
Yeah, the 76 million was correct. Actually, this is a credit, I think, to HDR and Burns and Mac, who worked with us in the conceptual design to get the letter of interest. That was part of the selling points for WIFI. Both the things you guys described was, one, it pairs the lowest cost financing, which is state revolving fund, with a very low cost WIFIA. And to Ron's point, we wouldn't have to start paying on the WIFIA portion until 2028. And so what the real benefit then is it lets us get the lowest cost of financing, state revolving fund, which locks in long-term savings for us. Plus, we get to lower the rate increases, so we have a much more gradual increase because we don't start paying on half of the project until 2028. And so this financing mix is unique in that it basically lets us pay the lowest possible costs on financing and lets us get the rates to down where they're 5-6% instead of 10%, which is what we would have to do on revenue bonds.
And we all wish we had that kind of mortgage, right? 2% and you don't have to pay for the first 10 years.
Since we're with staff real quick, I want to just sideline. The 508 was a great reveal. Thank you.
Yeah.
But I think the bigger surprise was the annual savings that you've identified through some operational efficiency. It's $6.18 million a year.
Yeah, now, so let me make sure we're clear on that number. This is a facility you're treating to a higher level of water quality standard, and you have a much more robust facility. So that doesn't mean I subtract $6 million from my current annual operations amount, right? This means if I built this facility as conceived, the price would be X. By optimizing the process in this facility, we can reduce that future operating cost by $6 million annually. That's what we're projecting.
Did we anticipate any of that in our projections when we were doing the possible rate increases, when we were doing our workshops, or was this a benefit at the end of the game for the ratepayer.
Well, this kind of crosses over into an operations and maintenance optimization program that we have going on right now. Is it the savings that we would get? Ron had described really well that we have this baseline concept that we had put together at the 5% design level to where we're at with this 30% design. We know that the 30% design will be much optimized from what we had initially. Then we have to compare that to what we actually do today. And we had included some of those savings as part of our operations and maintenance optimization. So some of this is already built into the rate.
But not at this level?
Not at this level.
Okay, so it possibly could have a better impact on the possible rate increases.
Yes.
Thank you.
You're welcome.
Any questions for me? Okay, thank you.
Thank you.
Do you guys have any others?
No, I think that this was a very thorough and accurate presentation of where we're at on this project. So I hope this is what the steering committee was looking for. And as always, if you have additional questions, just get them to us and we'll find the right answers for you.
No, I know we still have a little bit more work to do. Obviously, you identified some additional possible savings that staff's going to review. But this is a great way to end a Friday, to go into the weekend. Thank you very much. I know it's a lot of hours, but as I've said before, this is the single largest one-time project this city has ever taken on. And I'm thrilled that we've got a great team doing this for us and a lot of smart people, smarter than me, in this room working on it. So thank you.
Thank you.
Okay. So we'll keep everybody, the team here, so anybody that has questions, you can grab whoever you like from the team, me also. Thank you, everybody, for attending.
Yes.
Hopefully you have questions.